SPH4U forces in motion, 2.2 Newton's laws. Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in motion unless an external, non-zero net force acts upon it. This is also known as the law of inertia. Inertia is a tendency for a stationary object to remain at rest and a moving object to remain in motion in a straight line at constant speed. For example, a golf ball will remain at rest unless a club hits it and provides an external, non-zero net force which puts it into motion. Newton's second law states that if the external net force on an object is not zero, the object accelerates in the direction of the net force. This is given by the equation net force is equal to mass times acceleration. So now we'll go over an example of a question that employs Newton's second law. So if the mass of a ball is 9 times 10 to 2 kilograms and the force of gravity acting on it is 8.8 times 10 to 3 newtons down, and the force applied to the boat is 9.9 times 10 to the power 3 newtons up, find the acceleration of the bullet. So first let's write down our variables that we know. So we know that the mass is equal to 9.0 times 10 to the 2 kilograms, and we know that the force of gravity is equal to 8.8 times 10 to the 3 newtons down. And we also know that the force applied is equal to 9.9 times 10 to the 3 newtons up. So if we draw the free body diagram, it would look like this. So in this case, let's make up the positive direction. So first, let's get the net force. So force net is equal to Fa plus Fg. So that'll be equal to 9.9 times 10 to the 3 minus 8.8 times 10 to the 3, because 8.8 is going down. So this would come out to be 1.1 times 10 to the 3 newtons. So now we use the equation force net is equal to ma. So we had to isolate for a, so there you go. So we know that the net force is 1.1 times 10 to the 3 newtons, and all that over 9 times 10 to the 2, which is the mass. So that is equal to acceleration. So 1.2 times 1.2 meters per second squared up is equal to acceleration. One important difference that you should know is the difference between weight and mass. So weight, that's dependent on the force of gravity. So basically weight is equal to Fg. So that's equal to mg. Well, mass, that's the quantity of matter in an object. Its SI unit is kilograms. So if an elephant has a mass of 1,000 kilograms, its weight or is equal to Fg, so that would be equal to 1,000 times 9.8, so 9,800 newtons. So weight is the force of gravity acting on the mass. Mass is just the quantity of matter in that object. Newton's third law states that for every action there is a simultaneous reaction force equal in magnitude but opposite in direction. So if you push on a wall, force of U on the wall will push back force of wall onto you with the exact same magnitude but in opposite directions. So FAB is equal to negative FBA. So this is a problem involving tension, which also involves Newton's third law. So two boxes, A and B, of masses 6.7 kilograms and 5.6 kilograms respectively, are connected by a rope. The force of friction of box A is 9 newtons, while box B is 8 newtons. If the system is accelerating to the right, find the acceleration. So we know that the mass of A is equal to 6.7 kilograms. Mass of B is equal to 5.6 kilograms. We know that the force of friction on box A is equal to 9 newtons, and force of friction on box B that's equal to 8 newtons. So we can draw the free body diagram for this. So you have this box. So you have force tension 1 because these boxes are being pulled, and you have the normal force for box A, force of gravity for box A, and you also have this force tension between them, and you have force of friction for box B here. So in this case, for force tension 2, it's going both ways, as you know from Newton's third law. So this is the force normal for box B, force of gravity for box B. And here we have the force of friction for A. So as you see here, for force of tension 2, the magnitudes are the same, but opposite direction. Therefore, they cancel each other out. So we know that this is accelerating towards the right, so we just need to find the acceleration now. So initially we know that F net is equal to m times A. So we know this. We're trying to find this, but we don't know the force net yet. So in order to find the force net, we need to find all the forces that are going in the direction of acceleration, which is this direction towards the right. So F net is equal to Ft1 minus FFA minus FFB. So that would be equal to 29 minus 9 minus 8. So that's equal to 12 newtons east. So now we can plug this back into our first equation. It says F net is equal to ma. F net over m is equal to A. So in order to find the mass, we just add the mass of box A and mass of box B. So we have 12 divided by 12.3. So that's equal to acceleration, and that's equal to 0.98 meters per second squared east. So that was an application of Newton's third law in a physics question.